All right, this is the last video that I'm going to do for the in-class practice. I will do one more for the lab we did in class. So I'm going to do number 4. I have done 2 and 3 already. Oops, I didn't mean to do that. This one is kind of a cool one. I didn't mean to do that either. So let's start this off. Okay. So this one is a cool one. I like it. I like it a lot because it kind of gives you some different variables and lets you see how you can use what's going on. So it's kind of a cool word problem. This again is on page 143. So it's again on where your homework is. It's like application, if you will. So if a rock is thrown upward on the planet Mars with a velocity of 10 meters per second, and its height in feet after 10 seconds is given by this equation. So first of all, I want you guys to know, I'm going to label this first. Okay, so this is time in seconds. Oh, this is t squared. Time in seconds. And the height in feet. And this is cool because it's on Mars. But I also want to see this word velocity. And I want to remind you that velocity is like speed, but with direction. So it's a rate. It's a rate. And notice the rate was meters per second. So that's something I want you to notice. The other thing I want to tell you, and we're going to see this a lot, that this right here is called a position function because it tells you at any certain time what the position is of this rock that's thrown. All right. If you do the first derivative, if we do h prime of t, the first derivative is velocity or speed with direction. And that's interesting to know. So we're going to learn this more in other ones. So you have your position function is your first thing you get, where it talks about, where you are at a certain time. And you're usually talking about in time, and in this case, meters. All right. Now, when I do velocity, now it's a rate, and velocity is your first derivative. So if this was, in this case, we'll call this s of t. This will then be s prime of t. So the first derivative is velocity. And then the units are always like this, 10 meters per second, or something like that, where it's actual rate where you're comparing. And as we go along this year, we'll be doing a second derivative. And the second derivative, we show this double line notation. And the second derivative, for those of you that take physics, is acceleration. And then there is even one called for the third derivative, which is interesting as well. We use 3 little marks, and that's called jerk. All right. So those of you that are taking physics, you're like, oh, cool. So when they talk velocity, I just know I have to do the first derivative. Now, the other thing I want you to notice is as we're looking at this problem, they want me to find the velocity of the rock after 1 second. So I've got to do the derivative and find it after 1 second. But then as I go down this problem, it says find the velocity when t equals a. So they kind of want you just to find the velocity of the rock anytime. And then later on in this, for number D, letter D, you'll see that they're going to ask you what's the velocity when it hits the surface. So you don't want to just do the velocity for one, and then you got to do it all over again when you want to find the surface. So what we're going to do is actually find the velocity function. So I'm kind of going to do b first, and then we can plug in what's the velocity after 1 second, and then we can plug in what's the velocity when it hits the surface. So it'll save us a little work versus the ones we did before where they said just find it here and that's all you need to know. Okay, so I'm going to leave a alone right now because we're really going to find h prime of 1 when we're all done. But we're not done finding out what the function is, so we're just going to leave a spot for it. We're going to start and do b first. So I'm going to find h prime of t now because everything's in t's. So I'm going to actually use this function and put in t plus h instead of x plus h just because we're talking about time. And it helps you to see how this works a little bit better if I can mix it up a little bit like that. So I'm going to do 10 times t plus h minus 1.86 times t plus h squared. So there's that. And I'm going to take away or subtract 10t minus 1.86t squared. And it's all over h. A couple things I want you to notice. I actually put that in parentheses because I know it's all going to change signs. And it's the same as if we used X, but I'm going to use T because that's what we're talking about today. Now, again, this part right here, you can actually right here do that on the side if you want and make sure that you have that all done. I actually did that, so I'm going to kind of put it up here a little bit. So if you do t plus h squared, t plus h times t plus h, and you should be getting used to this, is going to be t squared plus 2th plus h squared. Now I just have to multiply them all by negative 1.86. All right, so I multiply all that, and that's what's going to go right here in that spot. So I have h prime of t is the limit when h approaches 0. And I'm going to do the distributive property here. So I have 10t. That's messy. Okay, let's try this again. 10t plus 10h. And then I did all of this, multiplied that all out like that. So it comes out to be this. You're going to have to trust me. Negative 1.86 t squared minus 3.72 th minus 1.86 h squared. So that's what that all is, and you can see it up there. And then I'm changing the signs here, distributing it. So it's going to be minus 10t plus 1.86 t squared all over h. Now again, as I go this, and I'm going to use Christmas colors. If we did it right, this whole back part should cancel, and it does. So thanks for playing. Thanks for playing. So now I have h prime of t. I love Christmas colors. Is a limit as h approaches 0. And I've got 10h minus 1.86 t squared minus 3.72 th. Okay, so that's all that's left there, all over h. Now I see I can't actually plug in the 0 yet, and I can see where I can factor out an h, but I think I did something wrong here. I think I forgot to cross this off. So let me erase this. I hate it when I do this when I video. So let's do this again. All right, so hang on a second. Where all my cross-offs are. Let's get rid of the cross-offs. See what I did? I put too fast. Okay, let's try this again. So I'm going to cross off the stuff that so this is canceled. This is canceled. I did the wrong thing. I'm so sorry. So I got h prime of t. Let's try this again. Is the limit. Now you know I'm human. Okay, so now we have 10h. Let's try this again. All right, minus 3.72 th minus 1.86 h squared. That's a 6 all over h. Now I can't, h approaches 0. Now I know I can't plug 0 in yet, so I'm going to factor out the h. So I have h prime of t is the limit of h approaches 0. And now I can factor the h out. So I have, when I do, I have 10 minus 3.72 t minus 1.86 h all over h. Then I can say, oh, thanks for playing. These divide out to make a 1. So this is going to equal the limit as h approaches 0 of 10 minus 3.72 t minus 1.86h. Oh, now we're getting somewhere. Now I'm going to do h prime of t. Now it looks like I can actually throw the 0 in there, so I'm happy about that. So when I do, I have 10 minus 3.72 t minus 1.86 times 0, which equals 10 minus 3.72 t. So now I know, and I'm going to write this one more time just so we have it nice and neat. H prime of t equals 10 minus 3.72 t. Now, by doing it this way, all right, again, I want to remind you, is now I can put any time I want and know what the velocity is at that time because I've done it for any kind of time I want to use. So that leads us to go back up to A. Now I have that function, all right there it is. Now I'm going to take it and just throw 1 in there. So that's beautiful. I can say, oh, all right, then that means 10 minus 3.72 times 1 equals 6.28. And I remember it's in meters per second. So that's how fast it was going after 1 second. And in actuality, after I'm doing this, I really should always label this meters per second. So anything I put in there is going to tell you how fast it's going at that time. So we just did A and B, right? Now let's do C. So C asks us, when will the rock hit the surface? So again, here's our formula. H equals 10t minus 1.86t squared. Now remember, when will it hit the surface? Well, it hits the surface when the height is 0. So this is not even calculus, folks. It's just saying, hey, can you tell me when this hits the surface? So I've got 10t minus 1.86 t squared equals 0. Now, I know you could use the quadratic formula, but I like to expand your brains a little bit. We're going to actually just factor out the 10t because they both have that in common. So if I take out a 10t, I have 1 minus, and it just moves the decimal over one place because I'm dividing by 10 equals 0. That's why sometimes this is way easier than the quadratic formula. 10t equals 0, time is 0. So that's right when the rock was thrown, it was thrown, it wasn't launched. Then I do 1 minus 0.186t equals 0. And then I'm going to move that to that side. So I have 1 equals 1.186t divided by 0.186t. So time comes out to be 5.376. And so we're going to say in 5.4 seconds is when this rock hits the ground. Now you'll see why for D. I'm so excited because D says with what velocity will the rock hit the surface? So they're saying, hey, this rock hits the surface at 5.4, but how fast was it going? Guess what? We have this wonderful formula that all I got to now throw in is the 5.4 to find out. So H prime of 5.4, so I'm going to use that, is going to tell us, hey, this is going to tell us how fast it was going when it hit. So we are able to use it more than once. So that's very helpful. So I'm going to throw the 5.4 in there. And when I do get that, I get a negative 10.1. And remember, this is always in meters per second. So that is how fast it was. Now, I want to remind you that velocity has a direction. So it's negative because it's going downwards towards the surface. So, but that's how fast it was going. It was 10.1 meters per second, and it's in the downward direction. So that is the end of the in-class practice that we did for today. So that's the end of this video as well.